Are you ready to listen carefully to my lecture? Okay, as I said before, topic is named as standard deviation and variance, standard error, confidence interval. Deviation just means how far from the normal. The standard deviation is a measure of how spread out numbers are. Its symbol is sigma. The formula is easy, it is the square root of the variance, and now you ask what is the variance. Variance is defined as the average of the square difference from the mean. Okay, I will take example later. To understand the meaning of the standard deviation of the mean, you have to understand the normal distribution. Look at the given picture. In Kazakhstan, we can observe that the average height of most Kazakh women is 160-170 cm, while standard deviation is going to measure the spread or variation in this curve. Firstly, look at the black line. So, 68% of individuals are in an area of 1 standard deviation. Green line, 95% of individuals are going to be within 2 standard deviation from that mean. And the last is red line, 99% of individuals are going to be within 3 standard deviation of the mean. It is more detailed graphical illustration, distribution of occurrences around the mean. 68% out of 100%. It is the distance of mostly spread numbers within 1 standard deviation of the mean. 95% out of 100%. It is the distance of mostly spread numbers within 2 standard deviation of the mean. 99% out of 100%. It is the distance of mostly spread numbers within 3 standard deviation of the mean. The next illustrations are also normal distributions. First of all, if my standard deviation is small, it indicates that my scores are close to the mean, and therefore the mean is a good indicator of the average score. On the other hand, if I have large standard deviation, it indicates that my scores are widely dispersed, and therefore my mean doesn't really tell me that much about the average score. To calculate the standard deviation of a set of scores, use the following formula, where the sum of squares of the differences between the mean and each score and the number of scores. For example, you and your friends have just measured the heights of your dogs in millimeters. The heights at the shoulders are 600, 470, 170, 430 and 300 millimeter. Find out the mean, the variance and the standard deviation. The first step is to find the mean. You know from the second lecture, the mean is obtained by adding all the values in a population or a sample and dividing by the number of values that are added. So you sum all measures and divide by sample size. Sample size is 5, because 5 dogs take part in your research. Of course, it's so small. It's just an example. Sample size can be 200, 1000, 20,000. It depends on your aim of investigation. So the mean or average height is 394 millimeter. Okay, let's plot this on the chart. Green line is the mean, 394, and the red lines are the height at the shoulders, 600, 470, 170, 430 and 300 millimeter. Now you calculate each dog's difference from the mean. Example is given in the green box. Take measure of height of the first dog minus the mean. So 600 minus 394. You can illustrate graphically the difference from the mean. The second step is to find the variance. To calculate the variance, take each difference, square it, and then average the result. So the variance is 21. The third step is to find the standard deviation. And the standard deviation is just the square root of variance. So standard deviation is 147. Now we can show which heights are within 1 standard deviation of the mean. So, using standard deviation, we have standard way of knowing what is normal and what is extra large or extra small. To sum up, first dogs are tall dogs and the third are a bit short. But there is small change with sample data. Our example has been for a population. The 5 dogs are the only dogs we are interested in, but if the data is sample, the calculation changes. Sample is a selection taken from a bigger population. Population standard deviation, we divide by n when calculating the variance, and sample standard deviation, we divide by n minus 1 when calculating variance. Confidence interval and standard error of the mean serves the same purpose, to express the reliability of an estimate of the mean. When you look at the scientific papers, sometimes the error bars on graphs or the number after means in table represent the standard error of the mean, while in other papers they represent 95% confidence intervals. You use standard deviation, coefficient of variation, to show how much variation there is among individual observations, while you use standard error or confidence intervals to show how good your estimate of the mean is. Okay, my lecture is over. Thanks a lot for paying attention. Goodbye.